Greetings again to everybody. Now today we are doing quadratic functions, and when they actually told you to solve a quadratic function to get the x's, and probably sometimes they ask you a question to get the zeros. Now for the quadratic function you should know that the equation should equals to 0. Now sometimes you get the whole equation which is equals to 0, but sometimes you get the equation I got which is not equals to 0. Now you should know the formula is ax squared plus bx plus c equals 0. What you're going to do is we're going to equal that equation to what the formula has. And that's what you're going to do. You're going to subtract minus 3x from both sides and we're going to subtract 3x from both sides and get 4x squared minus 3x minus 2 equals 0. Now you may get confused what is a, what is b, what is c. So before to get to any of those whatever formula methods we do for quadratic functions, I would recommend try to identify what you have as a, b, and c. So it's ax squared plus bx plus c equals 0. We know whatever has an x squared, the last thing before it is a. So 4 is a. Our a is 4. Now if you have x, the last one before that has to be b, so our b is minus 3. Do not forget the minus. And the c is the last thing by itself, and we have plus c, so if that is minus, then it's minus 2. Now that we have this, we have to look at whatever the rule is for us. So as I remember, if the a is less than 0, we have to do whatever fraction it is because it becomes minus or something like that. I think you have to get the minus out of that. I did a wrong rule here. You have to get the minus out of the equation and then do whatever those two tops tell you. If a equals 1, then you just do c over b and then start your factoring. So c multiplied by 2 and addition of 3, then what we should do. But in our situation, we have a more than 1, which means we have to multiply 4 to minus 2, which we get minus 8. Now in this situation, we cannot find any numbers that have the multiplication of 8, but add up to minus 3. So we can have something get the multiplication of minus 8, and then we have addition of minus 3. I couldn't think of any. So you're going to use a quadratic equation, which is minus b plus or minus b squared minus 4ac over 2a. Now again, if you did identify your ABC, it's going to help you in quadratic function. So you're going to use minus 3 because our b is minus 3. So it's the reverse of that to get positive 3. Now we have plus or minus square root of negative 3, again b squared, so negative 3 squared minus 4ac, so it's negative 4, our a is 4, negative 4 times 4, and our c is minus 2 times minus 2 over 2a is positive for our a, so it's 2 times 4, and that's how we apply it to quadratic function. Now we have to solve this. We do 3 plus or minus square root of 9 plus 32, that's the stop, so minus times minus 3 will become positive 3, negative 3 squared will become 9, positive 9, and then negative 4 times 4 is negative 16 times negative 2 becomes plus a positive 32, 2 times 4 is 8. Now we addition that one and get square root of 41 plus or minus 3 over 8. In this situation, 41 is not a complete square. What I mean is, if you do 2 square root of 2, you get 4, or get 3 square root of 2, you get 9. So 41 is not, if you go to that table, which we'll do later on, 41 is not a complete square because you have 36, which is 6 square becomes 36, and then you have 7 square, which becomes 49. So we don't have 41, in this very table. So you have to write, that's what the answer you get. You cannot get the 41 out to get like some decimal stuff like that. So you have to leave it like that. You do 3 plus square root of 41 over 8 and 3 minus square root of 41 over 8. That's how you actually should write it. Now sometimes maybe the question doesn't want you to do that, so you have to do 3 over 8 plus square root of 41 over 8 and then 3 over 8 minus square root of 41 over 8. So it depends how the question wants, how your structure wants it, how your professor wants it. But that's how you get it. Now if it's not like this, you should supposed to get like two numbers that are completely what do you call it, that are completely fixed. It is not like you have square root of imaginary numbers. But in this situation, I get it like this, and especially if you get complete one, then you have to apply it to the equation itself. We should talk about this in another video. Hope you guys enjoyed, and I see ya.